Good afternoon, everyone. Just jumping into another video here. My last video on stack creation seemed to have gotten lots of attention. So what I'm going to do now is, this is all part of a project I'm working on for my Ukrainian friends. What we'll do is we'll jump into a game I have. We'll look at the stack. And this game has an I variable within it. And if you overwrite the I variable, really simple, it just prints that I variable is overwritten with X, whatever it is, and you win. So it's a small game to get people used to stack creation and looking for variables within the stack to overwrite. These are exploit development basics that you really need to master. So I'm slowly putting together a training program for that. So enough talking. Let's jump right into our Linux where we all live. Okay, so here's our game. Okay, so it's a simple C program. And as you can see, the integer I is set at 0. We have a buffer of 64 bytes. Stir copy, which is vulnerable because it doesn't do bounds checking. I use stir copy or gets or whatever to get the basic point across. So basically, if I is greater than 0, because it's set at 0, if it's greater than 0, it means we overwritten that variable in some way. You have completed the challenge. I variable overwritten with X, and if you didn't overwrite the variable, it just says try again. I variable still 0. So with this one here, of course, we don't have exec stack, which is DEP. No stack protector, of course. We don't want to jump right into stack cookies yet. That's a couple weeks away in the training program here. So this is how you compile it as well. So I already have it compiled. So what I'll do is we'll jump into our terminal where we all live as hackers, and let's go. It's all on my desktop, and this is in my folder day 1. Okay, so ls-l, and as you can see, game is there. So excuse me, I'm going to do gdb/q and game. And of course, first thing you do is disassemble the main function. As you can see here, we push the EBP onto the stack. We then move the ESP to the same place as the EBP, so they're together. And then right here, you see the subtraction of 0x or 0x60 from the ESP. Let me just open this up a bit. So first off, let's find out the stack size. We will take a look at the stack creation in a minute, just to keep everyone thinking. So that's 96 bytes. So 96 divided by 4. So we're going to have about 24 words, which are 4 bytes. Words are 4 bytes. So about 24 words in hex for the stack itself. Plus you got the return address, plus you got the 2 argument functions on top of that too, right? So what I'll do right off the start, I'm going to display, let's go 34 words hex from the ESP. Okay, so now we're going to have 34 words of hex from the ESP down. So that should cover our base pointer, our return address, all that good stuff. I'm also going to display 2 instructions of EIP. So we'll see where our program's going next. I'm going to set a breakpoint. We'll set some breakpoints here, actually. So I'm going to set one. Actually, we already covered stack creation. So what I'll do, I'll just come right into the stir copy. We can find that right here. And this will show us, I'm going to put a breakpoint here so then I can just hit next instruction and it'll show us what we have overwritten with our inputs. And what I'm going to do now is run the program, and I'm going to put 12 A's for our input. We'll see where that goes on the stack. we'll find the I variable, and then we'll figure out how much it takes to overwrite it. And as you can see, this is building up to a buffer overflow, and is a nice little program to learn that. So right now we're at our breakpoint just at the stir copy. As you can see right here are 2 instructions of EIP. This is where we are, and we're just about to call the stir copy, which will put our input into the stack memory. So I'm just going to hit next instruction, and we can start looking for our 4 1s, 4 1s, 4 1s, which is A in hex. As you can see, that's our A's right there. So 4, 8, 12 A's. So let's have a look. We can print EBP. It's at C8. So let's find C, 3, 7, 8. So here is our EBP. So this one here is of course going to be our return address, but let's confirm that. We can go copy XWX and post. And as you can see, that goes to libc start main. So that's our return function. So now that we got that figured out, we know that this is our argc, which is 2, and this is our argv over here. So what we can do with this argv is copy, let's go xwx, this address, and it points to this address right here. So what I'm going to do, the 2 arguments that were mentioned in the argument count here, so I can go x, give me 2 strings of this address, and you should see the program name, the first argument, and then the second argument is our input of A's. So as you can see right here, here's the program, and A repeats 12 times. So that's some basics you have to look for when trying to do a buffer overflow. So now we figured out that where everything was on our stack. Next thing we're going to try to find is where is this I variable, and I just use and we take a look, and our I variable is at 0BC. So let's find B, and now C is 12 because in hex 10 is A, 11 is B, C is 12. So we come down to our C right here, 3, 7, 8, 9, 10, 11, and 12. So now we know where our I integer is. We can start. So it's 3, 7, 8, 9, 10, 11, and 12. So this right here is our I variable right here. And now that we know where this is, we can do the simple math of overflowing and trying to overwrite that variable. As you can see, our 12 only takes us to here. So we need 4, 8, 12, 16, 20, 24, 28, 32, 30, 36, and 37. So 37 more plus the 12. So what I will do, we will continue the program here. And as you can see, we exit it and it said, try again, I variable is still 0. Okay, so let's have a look here. So we need 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40, and 44, 48, 52, 56, 60, 64, 68. So I need 68 A's to overwrite this variable. And this is the basics of stack buffer overflow, finding these variables and overwriting things. So let's go, we can run the program, and we're going to use a little Python here because it makes things a lot easier than trying to just count out 68, I think it was. Let's do print And we'll throw our A's in here. You can use B, you can use X. A is nice because you just see to 41 and but like there's no rules to that really. And then we're going to go 68 times. So A times 68. I'm going to put the little tick in here and close it off. And let's see what happens. We're going to run again the program to our stir copy. And then from the stir copy, we'll take a look and we'll see if everything is overwritten. Okay, so we're right at our stir copy. As you can see, our I variable is right here, as we've seen before. Now we need to overwrite it. So I'm just going to do next instruction. And as you can see, it is now overwritten with our A's. Here it was before, the I variable. Now it's overwritten with our A's. Now, if we just hit C, you have completed this challenge, I variable overwritten with A's, and that is the game. Now, what you can do with this program too is you can change the buffer size and start getting into just learning how to tell how big the stack is and then figuring out how many A's, etc. You would need to overwrite these variables. So that's the little game just to teach people stack creation and overwriting variables on the stack. I hope you enjoyed. Yeah, I'm teaching my class on Monday, so I'm just getting ready for that. And I will get chatting to you guys after this weekend. So much love. I hope everyone's doing good, and I'll chat to you soon.